Hey guys, we're here with Noah from Uniswap. He's going to do a deep dive into Uniswap v2. Can you just confirm in the chat that you can hear him once he starts talking? That'd be awesome. Thanks.
Hey everyone. I'm not sure if I can see the chat. Let's see. Throw something in the chat if you can hear me. All right, I actually can't see anything, but
You're good.
okay. I'm just going to assume people can hear me. All right, so the way this is going to work is I want to just give a kind of a 20 or so minute overview of what Uniswap v2 is, and then give people a chance to ask hopefully some questions at the end. No promises on the timeline, but I'll try to stick to that. So without further ado, we launched Uniswap, announced a second version of the protocol a few weeks ago at this point, and we're very close to mainnet release. We've pushed everything to testnets, and we're just waiting on the final results of our audit, which have so far been, turned up no significant issues. But of course, we're just waiting for that to be final before we do launch on mainnet. But before that happens, we have been trying to kind of spread the word about what's new and why people might want to move over from V1 to V2. So let's hop right into kind of the new features that we've introduced in this new version. So I'm going to go through this checklist here kind of in order. All right, so create two factory is the first thing I want to talk about. Like in V1, we have this factory kind of pair pattern where tokens that exist on Uniswap can be kind of created through this factory, and then a pair is instantiated, and the pair is responsible for trading between two particular tokens, like DAI and ETH, let's say. So a significant upgrade to this pattern that we made in V2 is that we're now using Create2, which is this new opcode that got introduced in Istanbul. And what Create2 lets you do is do deterministic creation of smart contracts. So the way it works is there's a bunch of data that is fed to a hash function. The hash function distills it down into a single kind of identifier, and that identifier is what determines the address of a smart contract. So in our case, we're given two token addresses, DAI and some other token, MKR, let's say. We feed those to this hash function, it distills them down, and then that seed determines a unique address for the pair. So when you're creating the DAI MKR pair, for example, you can actually feed this data. You can simulate the process that the factory goes through to create the pair for DAI and MKR. And you can do this off-chain and compute what that counterfactual pair address would be. And this is useful in a lot of cases when you're kind of deploying systems and you kind of want to do everything in a synchronous way when you're, for example, creating a contract or something like that. So this Create2 opcode, which we've added right here, gives us this deterministic pair address characteristic, which we think is pretty nice. So that's one kind of fun little upgrade. The second one I'd like to talk about is this core helper separation. So in Uniswap v1, if you've ever interacted with the smart contracts, it's basically just a really long exhaustive list of functions for swapping tokens in a variety of ways. So there's lots of ETH special case functions. So for example, like there's a swap token to ETH function. There's also a swap ETH to token function. And then there's a swap ETH to token and then send it to a sender function. There's a swap tokens for, ETH for tokens and then swap that to a sender. So that, there's like 30 or 40 functions or something in Uniswap v1, which is, fine, it works, but it can get a bit cumbersome. So in v2, what we decided to do is create this extremely simple minimal core contract that is extremely, it's very minimal, it has about 4 functions, and it's very easy to kind of reason about in a logical mathematical way. And then we've kind of pushed all of the external kind of utility style functions to external smart contracts that can interact with the core in a safe way, and then make any safety checks they need to before sending along the tokens to their final destination. So this is really going to help us in terms of just generalizing and making the code base more robust to further extensions and new ways of chopping and slicing and dicing tokens from one person to the other, which is ultimately what Uniswap does. Okay, so that's core helper. The third thing I'd like to talk about, and I kind of alluded to this like at the beginning, I guess, by referencing DAI and MKR as a pair, is that we've opened up the kind of base currency. In Uniswap v1, ETH was a forced base currency for every pair. And so, in order for a token to be traded on Uniswap v1, it had to, have an ETH pair essentially. In V2, we've relaxed this restriction, and so now any ERC20 can be paired with any ERC20, and we've actually outlawed ETH. We've basically made it such that you can only pair ERC20s and not ETH. And so to get around that, we're now using WETH essentially as a base pair. If you do want to use, if you do want an ETH pair, you actually have to use WETH. This isn't actually as annoying as it sounds because, per the second point, this core helper separation, the wrapping and unwrapping of ETH to WETH can actually happen in a helper. And so it can actually be totally abstracted away from a user. And so, when you're using an interface or, any type of tool that's relying on Uniswap liquidity, you're never going to actually have to use WETH. The wrapping and unwrapping of your Ether is going to be done at this kind of helper level. And then the helper is going to be interacting with the core with WETH. So yeah, that's kind of a really nice feature. And we're super excited for, stablecoin pairs. And we think it's just a nice way to open up the kind of pool of pairs. Okay, so the fourth thing I want to talk about before we move on to the next section is permit. So there's been a lot of talk about meta transactions for a while now in the community. They're a way to essentially smooth over some UX pain points when you're sending tokens along to smart contracts in order to programmatically execute some pattern. There's been a lot of proposals for how to do meta transactions in a good way. Not a lot of them have gotten traction. A permit is one that DAI, I think, first introduced in their MCB contracts. It's a very kind of generalized way of signing a message as an Ethereum address that permits an external smart contract to withdraw your tokens on your behalf and then do something with them. It uses ERC 721, which is a signature standard. You should read all about it. There's actually an ERC that Martin Lundfall, who has been a kind of the creator and champion of permit in its use in DAI as well as Uniswap v2. He's written an ERC about this new permit kind of standard, and so I recommend that everyone kind of go look at that. But we are going to be one of the contracts that's going to support this kind of new standard, so we're pretty excited about that. Okay, so let's move on from the kind of generalized overview of the V2 smart contracts and dive into oracles. So one of the top line features of V2 is going to be decentralized price oracles. And so if you're not aware, Uniswap v1 is not safe as an on-chain source of the price of two tokens. And so the reason for that is very, very simple. In theory, if there's a DAI pair and let's say a DAI ETH pair on Uniswap v1, you expect the price of that pair to kind of track off-chain prices, right? Because if the price on some off-chain or even external exchange, dramatically increases or decreases, there's an arbitrage opportunity there, and so you're expecting someone to kind of swoop in and take that and normalize the price. But as a smart contract, without some kind of external source of knowledge of what the DAI ETH price is, you can't rely on the Uniswap v1 price, because if a contract naively kind of reads this price and says, hey, Uniswap, what's the price of DAI ETH right now? Someone can see that kind of read action is occurring while the transaction is in the mempool, and they can actually front run that transaction by trading a dramatic amount of DAI or ETH, changing the price. The oracle, this contract that's reading the price sees a really incorrect value, but doesn't know any better, right? Because it doesn't have an external source of truth. And so this kind of front running behavior in Uniswap v1 leads the v1 basically to not be a very robust source of price information for use cases without an access point to the real kind of price off chain. And so how we've ameliorated that in v2 is with an oracle system, which I'm about to explain. So let's dive in. The first bullet point here is called prices. And so what that basically means is that we've decided that the best way to represent a price is a price. And that might sound super obvious, but it's actually not. So in Solidity, as many of you hopefully know, integers are the only kind of native numeric data type that are supported, floats are not. And a price is ultimately, it's a float, right? It's a fraction, but basically it's a non-integer numeric value. And so we decided to represent prices as basically prices. And to do that, we had to introduce binary fixed point data types. And so we did that in a fairly straightforward way. It's actually not that complicated. Basically, it's a certain number of bits before a digit, and then a certain number of bits after the digit. So it's like 123.456, and we've represented that in a nice kind of concise way in Solidity. And so that's what a price is. It's DAI ETH. We have the price of DAI over ETH, and we represent that as a kind of a decimalized value. Okay, so the next thing to consider is what prices do we want. So there's lots of different prices actually. That on Uniswap, there's a price for pair, at every kind of instant, and every trade moves that price. And so we thought that the most reasonable price that we'd want to track is the one that basically the block ends at. So within a block, there can be any number of trades that move the price up, down, exclusively up, then down then up, etc. But ultimately, what really matters is what price the block ends at, because that price is the one that's going to be open to arbitrage at the beginning of the next block. And so, if the price starts at some value, it's traded a bunch, and then it lands at 120. That price of 120 could be arbitraged up or down in the next block if it's wrong. And so essentially, there's a big incentive to trade the token price on Uniswap to the price that it's reasonably is off chain. And so this kind of ending block price is what we actually care about, and that's what we're tracking. And we've done that basically by every time someone calls the contract says, okay, I'm being called, I'm waking up, what was in it? Then it looks back and it says, what was the price as of the last time anyone interacted with me? And so it looks back to these basically data structures that it's storing in its memory. And then those values are what it uses to update kind of its knowledge of the price, right? So what does this updating actually do? It's an accumulation. So, right, someone calls a contract function on Uniswap. Uniswap says, okay, what was the price as of the last time someone interacted with me, right? At the end of the last block. And then let's just say it's 100. What it does with that 100 is it adds it to the cumulative sum of all prices that it's ever observed for this pair throughout history. So let's say that this is like the first interaction ever, right? So the price starts at, or the accumulator rather, starts at 0. A block elapses, and Uniswap says, oh, the price was 100 last block. So that means that for the duration of a single block, the price of this pair was 100 over 1, right? And so it adds 100 to this accumulated value, so it goes from 0 to 100. The next block, let's say that nothing happens, no trades occur. The price is still 100. So it adds 100 again to 100, and it gets 200, right? So you get 0, 100, and 200. Now let's say someone trades the price down to 50, and then 4 blocks go by. Right, we take 50, which is the new price, we multiply that by 4, 200, and then we add that to 200, which is 400 now. And so, we get a total of 6 blocks that have elapsed, and this accumulator value has gone from 0 to 400. And so you can kind of maybe see it already. The way to actually back out the average price over the interval is to take the ending value, the beginning value, divide, and then that price is the average price over the entire duration. And so this characteristic is what we've relied on, or is what we kind of leverage in V2 to get accurate interval averages for the price of on-chain assets. And finally, what's required to actually use this in a meaningful way is external differencing. So this accumulator value is just ticking up, ticking up, ticking up, ticking up. And for the entirety of basically Uniswap V2's duration, on every single pair, these values are just going to be ticking up and up and up. So to actually use these in a meaningful way, an external smart contract has to read the value at a point, and then wait some duration, read it again, and then do this differencing that I discussed. So, maybe if it reads it once, waits an hour, reads it again, does the difference, it can compute the average price over that hour. So the Oracle does require this kind of, this kind of, checking, this periodic basically checking of the values in order to extract meaningful price data. So, okay, that's Oracles. I'm making good time here, so we're still gonna have time for questions. The last thing I want to talk about is flash swaps. So one of the other top line features that we have introduced in V2 is flash swaps. And so flash swaps have gotten a lot of attention recently, some not so good attention because they've led to exploits or kind of the discovery of bugs in certain smart contract systems. We at Uniswap definitely don't, we want to do this in a really safe way, but we do think that there's actually a lot of value to be had in this feature. And so we made the call to introduce flash swaps, and we kind of have we have a variety of kind of safety conditions that we're enforcing on our end. And I think that the existence of flash swaps, whether or not we do it or someone else does it, they're out there and they're happening. And so I think it's important that we make our systems as robust to these this kind of new pattern of activity as possible. So without further ado, I'm going to jump into how we at Uniswap introduced flash swaps. So this first point I have is generalized invariant. In Uniswap v1, the way to trade an asset for another asset was to ask for as much of the output as you wanted, basically. And so you would go to the contract and you'd say, hey, I have 100 DAI. Give me as much ETH as you can, according to your pricing formula, and I'll just take that and I'll check it. And if it's not enough, I'll return it. But if it's enough, I'm just going to keep it. And that's what Uniswap v1 did. Uniswap v2, on the other hand, is actually agnostic to how much output you request, as long as a condition is satisfied. And that condition is basically the satisfaction of x times y equals k, which is a constant product market maker formula that Uniswap uses to enforce its trading activity. And basically what that states is that the product of asset values in a pair has to increase after every trade. So if there's 100 DAI and 50 ETH or whatever, the product of that is 5,000. If that product doesn't go up after a trade, that's not a valid trade. But if it does, it's valid. And of course, there's no upper bound on how much better the invariant can get, right? It can get way, way better. There's a minimum amount that it has to get better though, right? And it's not actually zero, as as the perfect kind of x times y equals k formula would suggest. It's actually a bit more than zero. So it actually has to increase. And it has to increase by the amount of 0.3%, right? Which is our pretty standard liquidity provider fee, which is the amount that basically incentivizes liquidity provision on a pair. So where the generalized invariant nature of flash swaps comes into all of this is that when you're performing a flash swap or even a normal swap on Uniswap v2, you're not actually just giving an amount of tokens to the contract and then getting back as much as you could have. You're actually responsible as a caller of the contracts to specify which amount, how many output tokens you want, essentially. And so this gives you the flexibility to perform any kind of arbitrary slicing and dicing of the token amounts in a way that wasn't possible in v1, right? In v1, again, it's like input, output. But in v2, you can send in as much of either token as you want, and you can request out as much as you want of either one as well. And the only thing that the contract cares about is that at the end of the call, it has received enough tokens and not sent out too much, such that the invariant x times y equals k, accounting for the fee as well, is satisfied. And so that basically lets us do flash swaps. And so how does that work? If a caller doesn't have any tokens, but it wants 100 DAI because there's an arbitrage opportunity, let's say, it can request out 100 DAI, receive that, use it externally in a callback function to, let's say, do some arbitrage and get back ETH. It can then send that ETH as WETH to back to Uniswap. And Uniswap at the end of the trade can say, okay, I sent out 100 DAI. I've received, however much WETH I received. And then it can just run the math, check x times y equals k. And if there's more tokens in basically after the trade has occurred than before, it says, okay, you're good to go. And so the person basically got this flash loan of 100 DAI actually for free, right? Because they got those tokens and then they paid in WETH, and all that Uniswap checked was that, hey, that the WETH price, the amount of WETH we received was enough. And so this is actually a really nice behavior that we couldn't have got with an external flash swap. With an external flash swap, you would actually be forced to pay the fee on that output amount that you got, that initial kind of 100 DAI that was sent to you to use in your callback. But because we've kind of in-housed the flash swap functionality to Uniswap, you get this flash swap for free, which is really nice. You can also do single asset flash swaps. So this is where you do have to pay the fee, right? If you're taking out one asset and sending back another, that's where you get the free flash swaps. But if you're just taking out one and sending the same one back, so you ask for 100 DAI and you're sending some amount of DAI back, you do have to pay for that. And so we think this is a really nice kind of way to sort of like incentivize trading, of course, but it's actually really natural just to the way that the Uniswap v2 kind of whole system works. And we're really excited for it. In a lot of use cases, but in particular, no capital arbitrage is going to be a really exciting thing that we're going to see from flash swaps. If there's an external arbitrage opportunity, you're not going to need capital to exploit that, right? Because you're going to be able to, take some asset from Uniswap, synchronously execute the arbitrage, return as much of your profits as you need to Uniswap to kind of satisfy the invariant, and then you can keep any remainder that you've made. And so this is going to kind of democratize the the arbitrage market, and it's going to just further increase all the characteristics that make Uniswap valuable in the first place, right? Which is the on-chain prices track the off-chain prices, high trading volume and high liquidity. It makes the oracles that much stronger, and et cetera. So that is a check mark for fee calculation. I already talked about that. And I think that does it for my list here. So I'm going to switch back to the chat and see if there's any questions. Oh, there are. Great. Okay, so I have 10 minutes as expected. So Yukai Rex asked, why not Viper? It's a good question. So yeah, as some of you may know, V1 was written in Viper, and V2 is in Solidity, as you can maybe see here. I didn't go through as much of the code as I thought I would, but take my word for it that it's Solidity. There was an audit that was released after Uniswap V1 launched and before Uniswap V2 development started, of the Viper compiler, and it turned up a number of issues that were fairly worrisome from a security perspective. Prism Labs is using, or Prismatic Labs, I guess, is using Viper for its ETH2 deposit contracts. It's not like Viper is like irreparably, kind of broken or anything, but because we had this kind of very tricky, price oracle accumulation logic that we were writing, because we wanted to access some of the newer features of the EVM, like Create2. We decided that Solidity was just a better bet for us at the moment, rather than having to try to work with the Viper devs to introduce these kind of new cutting edge features. And as you can see, actually, this Create2 we're using in the factory is actually a low level assembly call. And so that's something that, isn't available in Viper, for example. And so it just really didn't meet our requirements for V2. And also Solidity is just a more generally widely used, programming language for smart contracts. And so we felt a bit more comfortable writing it in Solidity. All right, the next question that I see is, what problems has the team run into while developing V2? So this is a really interesting one. I'll talk about one specific thing. There were lots of issues. You can actually check like the GitHub issues backlog, the closed issues on the Uniswap V2 core repo, if you want to know some of the specifics. But one big thing was that Uniswap V1 has this issue where incorrectly implemented ERC20 tokens, which don't return a bool value from their transfer or transfer from functions, which they're supposed to, actually break Uniswap. They don't work in Uniswap V1. We wanted to fix this in V2, even though technically it's a bug of the token implementation, there are ways that we can kind of get around this in the V2. And the way we did, which I can actually show you, is right here, safe transfer. So what this does is it basically encodes a low-level transfer call to a token address, and then it gets this success value and then this data value. So for tokens which don't return a Boolean about indicating the success or failure of the transfer, this data parameter has length 0. And so you can see that we're checking that either the data parameter length is 0 or the decoded value is true. And so that lets us lets Uniswap V2 work with tokens who do and don't return a Boolean on their transfer function. So this is just one example of the things that we've done to kind of make Uniswap V2 as robust as we can and as kind of as failure proof as we can. What are the biggest challenges, ideally not AMM specific, that Uniswap is facing? How can the community help? This is an interesting question. I mean, I'm not an expert here by any means because I'm primarily just a developer working on the kind of technical challenges that we're facing. When it comes to kind of broader questions, always the biggest issue is kind of mainstream adoption. We want as many tokens as possible to be available for trading. We want to make sure, so recently UMA, which is a decentralized finance project based in New York, had a fairly successful, fairly interesting kind of token sale of sorts. Don't take my language for much of anything, but they kind of performed this pretty interesting exercise on Uniswap V1, and there were a lot of really interesting learnings I think that we saw from this. And so I think that using kind of AMMs like Uniswap and this kind of new model of decentralized liquidity provision and trading and all this stuff, using that to kind of expand the range of things that that people are able to do with Ethereum is going to be really exciting. And so we've, for example, also, just to give another example, explored some of this with Unisocks, right? So Unisocks is this thing that we created, a year or so ago now, and we kind of created this token which represented the rights to a digital sock. We sold these on Uniswap. People bought them for ETH. The price went up, along the Uniswap curve, and then we actually ended up sending out, physical socks to people. And this kind of interesting. This behavior is kind of really what we want to encourage and keep seeing. And we want Uniswap to kind of be this fundamental building block layer for all these economic experiments. All right, I have 5 minutes left, so I'm going to try to go a little quicker. When will be deployed approx V2? We're just waiting on the results of our audit. It's going to be very soon. The official date is Q2 2020, which is, we're in Q2. So I'll just say very soon. I can't really commit to anything more, but quite soon. Is it correct to say that the price oracle would give the relative price of the asset over a period and not an absolute value, which could be off-chain? I don't know exactly what you mean, but I'll try to take a stab. So there is this perfect average price that you could compute, right? Like if you take the ending block price at every single block on Uniswap V2, there is some perfect number, right? That is the average over whatever, arbitrary interval you care about. And so you're never going to be able to replicate that perfectly on chain unless you're yourself checking every block, which is like prohibitively expensive, right? And so the way to think about less frequent observations is just that you're adding a bit of noise, right? So if you wait for like 24 hours to check the price differences, you're going to get a perfect 24-hour average, right? It actually will be perfect. That's definitely true. But what it won't be is perfect if you were, it's perfect assuming that you only have knowledge at the beginning and the end of the interval, right? If you have knowledge at the beginning, the middle, and the end, that number that you compute is going to be different, and it's going to be like slightly less noisy, but it's not incorrect, right? It's just like a statistical kind of, it's like a bias variance trade-off thing, right? You get higher variance when you check less frequently, but the bias, the correctness in some way of those estimates is the same in both cases. How do you plan migrating from V1 to V2? V1 is perfectly permissionless. There's nothing we can do to stop V1. It's going to exist for the entirety of ETH 1.0's existence, and we're super happy about that. And V2 follows the same pattern. It's always going to be there. So we just have to incentivize people by writing cool new features, which we tried to do. We think the oracles and flash swaps and the variety of quality of life improvements that we've made in V2 are going to incentivize people to move over. We're building a lot of tooling on top of V2 that's going to make it even easier for liquidity providers and traders and basically community members to integrate with the V2. So we're really looking forward to that. Can you talk about the difficulty of adding flash swaps and security reentrancy from Ben? Yeah, so again, that's one of the things I was kind of alluding to when I mentioned the security issues around flash swaps. Security is basically our number one priority when we're releasing new smart contracts, and we basically added a mutex lock to every function on Uniswap V2 core, and that's another benefit of this core helper separation. We didn't have a million functions that we needed to mutex. We had like 4. So it's basically the swap function, the add liquidity function, the remove liquidity function, and so we added just a quick little mutex, which basically, for those of you who don't know, ensures that after a function is called, a switch gets flipped, and until that function kind of exits and kind of clears its scope, it can't be re-entered into because of this switch. And so it's a bit of a kind of a blunt instrument, to be honest, if we're thinking about the best ways to kind of combat these kind of difficult, tricky security issues. But it's pretty foolproof, we think, and basically a flash swap has to be atomic in the sense that you can only do a single flash swap, not per block, but kind of per atomic unit of interacting with Uniswap. You can't interact with Uniswap in the middle of a flash swap. You have to do it either before or after. All right, last question, I think, really quick. Will there be an easy to use front end for the flash swap feature on the main Uniswap website? We're launching super soon, so no is the answer. We're gonna have an interface for like normal trading, normal adding liquidity, all that stuff. For these kind of more advanced features, like as I mentioned, no capital arbitrage, et cetera, even just like normal use of flash swaps, we're not going to be supporting that off, from the bat on the front end. That being said, we're going to be building tools around this. We're going to be offering support for this, as soon as we can down the road. But also, we're going to be giving people the support they need to integrate on a smart contract level as well, and add this to their interfaces in whatever way they choose. So That being said, I think I'm out of time. For more information on V2 and to get in touch with me or Hayden or anyone, check us out on uniswap.org, uniswap.org. There's lots of information. There's documentation, fully comprehensive documentation on V2. All of our code is open source, GPL. It's on GitHub. Check it out and feel free to reach out. Thanks so much, guys. And I think that is it for me.
Thanks, Noah. That was great. All right, we're going to transition to the next session now.